Good morning, students. Yesterday, we have discussed about the depression in freezing point and the relation between the molar mass of solute and the freezing point depression, as well as we have discussed about the elevation of boiling point, lowering of vapor pressure. These the qualitative properties. Now today we will discuss about the osmotic pressure. Besides the boiling point of elevation and the freezing point depression, the osmotic pressure is associated with the vapor pressure lowering and can be used to determine the molar masses of the dissolved solute. This is another qualitative property, that is the osmotic pressure. Before knowing about the osmotic pressure, we must know about the few terms, that is the osmosis and the semi-permeable membrane. Semi-permeable membrane. म्हणजे ऑस्मॅटिक प्रेशर म्हणजे काय हे पाहण्याच्या अगोदर आपल्याला या 2-3 गोष्टींचं माहिती असणं आवश्यक आहे. सेमी परमेएबल मेम्ब्रेन म्हणजे काय? प्रोसेस ऑफ ऑस्मोसिस मीन्स व्हॉट? When we are talking about the semi-permeable membrane, the osmotic pressure phenomena involves the use of the semi-permeable. It is nothing but it is a thin film such as the cell foam which has the pores large enough to allow the solvent molecules to pass through them, and these pores are the small enough not to allow the passage of the large solute molecules up and through the of high molar concentration. The semi-permeable membrane selectively allows the passage of the solvent molecules. म्हणजे आपण या ठिकाणी आपण सेमी परमेएबल मेम्ब्रेनच्या बाबतीमध्ये विचार करत असताना सेमी परमेएबल मेम्ब्रेन इज नथिंग बट इट इज अ थिन फिल्म. थोडक्यात इट इज एक पातळ असा पडदा आपण ज्याला म्हणतो आहे, ज्याच्यामधून की सॉल्व्हंट मॉलिक्युल्स छोटे छोटे छिद्र जे आहेत या छिद्रामधून सॉल्व्हंट मॉलिक्युल्स पास होऊ शकते. बट another thing here we have to consider, we have to take in mind that is the larger molecules can't flow through them, can't pass through them semi-permeable. It is a thin film like the cellophane which has the pores large enough to allow the solvent molecules or the molecules of the solution which are having which are the dilute solutions, for example, not the concentrated solutions. म्हणजे त्याच्यामधून हे जे काही सॉल्व्हंट मॉलिक्युल्स जे आहेत हे सॉल्व्हंट मॉलिक्युल्स सहजगत्या एका पास होऊ शकतील अशा पद्धतीचा एक पडदा ज्याला आपण म्हणत आहे, that is a thin film, is called as the semi-permeable. Then about the process of the osmosis. When a solution and the pure solvent of the two solutions of different concentrations are separated by a semi-permeable membrane, the solvent molecules pass through the membrane. म्हणजे या ठिकाणी आपण एक बाब लक्षात घेतली. In this figure, this is the semi-permeable membrane. This is the solvent and the solution, and this is the flow of the solvent. म्हणजे या थ्री फिल्मच्या मधून this is the solvent molecules and this is the solution. And here, this is the net flow of the solvent. When a solution of pure solvent and the solution of two different concentrations when we are taking in consideration, at that time they are separated by a thin film that is the semi-permeable membrane. And the solvent molecules pass through this semi-permeable membrane. That process is called as osmosis. In other words, we can say that here, instead of the pure solvent and the solution, we can take the two solutions of different concentrations. Solution of lower concentration and the solution of higher concentration. But the net spontaneous flow of the solvent molecules into the solution from more dilute solution to the more concentration solution to the semi-permeable membrane is called as the osmosis. म्हणजे या ठिकाणी आपण या फिगर मध्ये पाहिले की सॉल्व्हेंट मॉलिक्यूल सॉल्व्हेंट and pure solvent and solution हे दोन या ठिकाणी and the flow of the solvent is in this direction from solvent molecules to the solution. Instead of this, we can take the solution of the more concentration and the solution of the less concentration. Means the solutions which are having the two different concentrations. And the dilute solution it passes through the semi-permeable membrane towards the more concentration solution. That process is called as the osmosis. म्हणजे जो कि net spontaneous means what? That is the continuous flow of the solvent molecules into the solution from the more dilute solution to the more concentrated solution to the semi-permeable membrane is called as the osmosis. As a result of the osmosis, the amount of the liquid on the pure solvent side or the more dilute solution side decreases consequently, and the amount of the liquid in the solution of the more concentration side increases, and this results in the decrease in the concentration of the solution. म्हणजे हे जर डायल्यूट सोल्युशन असेल या डायल्यूट सोल्युशनचं इकडच्या कॉन्सन्ट्रेटेड सोल्युशन मध्ये हा थ्रू या सेमी परमेबल मेम्ब्रेन मधून जर पास होत असेल ॲट दॅट टाइम द कॉन्सन्ट्रेशन ऑफ दिस मोर कॉन्सन्ट्रेटेड सोल्युशन विल बी डिक्रीज and the amount of the solution of the dilute solution it will be decreased due to the flow of the dilute solution molecules towards the more concentrated solution. म्हणजे ही जी काही फ्लो जो आहे ही जी प्रोसेस जी आहे That process is called as the osmosis. Then we have to come towards the main point, that is the osmotic pressure. The osmosis can be demonstrated by the experiment. The semi-permeable membrane is firmly attached at the low across the mouth of the thistle funnel, and the solution of the interest is placed inside an inverted thistle tube. The part of the tube and membrane are then immersed into the constant container of the pure water. At that time, as a result, after some time, we will see that some of the solvent passes through the membrane into the solution. It causes the liquid level in the tube to rise. And the liquid column in the tube creates the hydrostatic pressure that pushes the solvent back to the membrane into the container. And the column of the liquid on the tube continues to rise, and that pressure is called as, when an equilibrium is established. When an equilibrium is established where the rate of the forward and the reverse process are equal, the height of the liquid column in the tube remains constant, and this impels that the hydrostatic pressure has stopped the osmosis. म्हणजे ऑस्मॉसिसची प्रोसेस जी आहे ही प्रोसेस त्यावेळेस ती स्टॉप होत असते. आता दुसरी बाब जी या ठिकाणी आपल्याला पाहिजे ती म्हणजे अबाउट द सोल्युशन्स. isotonic solution, hypotonic solution, and the hypotonic solution. म्हणजे तीन प्रकारचे सोल्युशन्स जे आहेत, आयसोटोनिक, हायपोटोनिक आणि हायपरटोनिक. आयसोटोनिक सोल्युशन, hypertonic solution, and the hypotonic solution. In that, when we are talking about the isotonic solution, two or more solutions having the same osmotic pressures are said to be the आयसोटोनिक सोल्युशन. म्हणजे आयसोटोनिक सोल्युशन मध्ये दोन्हीही सोल्युशनचं टू or more solutions which are having the same osmotic pressure, same osmotic pressure in the case of the isotonic solution. In case of the hypotonic solution, if two solutions have unequal osmotic pressure, and the more concentrated solutions with the higher osmotic pressure is said to be the hypertonic solution. In the hypertonic solution, the two solutions are having the unequal osmotic pressure. They are not having the same osmotic pressure. In this case, unequal osmotic pressure. And the solution having the more concentrated solution with the higher osmotic pressure is called as the hypertonic solution. The more dilute solutions exhibiting the lower osmotic pressure is said to be the hypotonic solution. म्हणजे ज्याचं कॉन्सन्ट्रेशन हाय आहे to hypotonic, and in this case the concentration is less. And the osmotic pressure is unequal. Such a solution is called as the hypotonic. Isotonic, hypertonic and hypotonic. Isotonic solution in which both the solutions are having the same osmotic pressure. In case of the hypertonic solution, the solutions are unequal in the osmotic pressure, but the solution which has the more concentration is called as the hypertonic solution. And the solution which has the less concentration, that is the hypotonic solution. म्हणजे isotonic, hypertonic and hypotonic, these are the three types of the solutions. Then the osmotic pressure and the concentration of the solution. When we are talking about the concentration and the osmotic pressure of the solution, the every dilute solution, the osmotic pressure is followed the equation, that is the pi is equal to N2RT by the volume, that is V. Where N is the number of molecules, R is the constant, T is the temperature, and V is the volume. That equation is followed by the dilute solutions. In the case of the osmotic pressure, where V is the volume of the solution in the DMQ or meter cube, containing N2 number of moles of the non-volatile solution. R is the gas constant and pi is the osmotic pressure. म्हणजे जे की आपला आयडियल गॅस इक्वेशन काय आहे हो, PV is equal to NR. या ठिकाणी काय होईल, pi V is equal to N2R. That is the pi is equal to N2RV by V, where pi is the osmotic pressure, N2 is the number of moles, R is the gas constant, and T is the temperature, while the V is the. म्हणजे साधा आणि सोपे हे आयडियल गॅस इक्वेशन वरून असणारे जे इक्वेशन जे आहे हे इक्वेशन दिस इज फॉलोड बाय द ऑस्मोटिक प्रेशर in this case for the dilute solutions. In this case, one should be note that the solute concentration is expressed in the molarity. Find the calculating the osmotic pressure rather than the molarity. But in this case, we have to solute concentration have to measure in terms of the molarity, not in terms of the molarity. Then the molar mass of the solute from the osmotic pressure, it is calculated with the example with the formula, that is pi is equal to N2RT by V. If the mass of the solute in V liters of the solution of W2 and its molar mass is M2, then N2 is equal to W2 by M2. म्हणजे नंबर ऑफ मोल्स काय असतील, जर त्याचा वेट जे आहे W2 असेल, मोलार मास त्याचा M2 असेल, at that time the number of moles is equal to N2 is equal to W2 by M2. And with these values of the number of moles, that is N2, we have put this value into this equation, that is pi is equal to RT N2RT by V. म्हणजे या ठिकाणी आपण फक्त N2 ची व्हॅल्यू पुट करतो, pi is equal to N2 काय आहे, W2 by M2 RT by M2. म्हणजे हे मोलार मास कॅल्क्युलेट करत असताना या ठिकाणी काय आहे, फक्त M2 is equal to W2 RT by pi, that is the molar mass. We have to calculate with this formula. This is the relation between the molar mass of the solute from the osmotic pressure. म्हणजे या ज्या काही बाबी ज्या आहेत, जे काही आपण आता या ठिकाणी क्वालिटेटिव्ह प्रॉपर्टी म्हणजे जे काही आपण ऑस्मोटिक प्रेशरच्या बाबतीमध्ये पाहिलं, त्याच्यामध्ये सेमी परमेएबल मेथड, ऑस्मोसिस, त्याच्यावरून मग ऑस्मोटिक प्रेशर म्हणजे काय आपण पाहिलं. Then about the solutions, that is the isotonic solution, hypertonic solution, hypotonic solution, and the osmotic pressure and the concentration of the solution, that is which is given by the equation, that is pi is equal to N2 RT by V, where pi is the oscillating pressure, N2 is the number of moles, R is the constant, T is the temperature, and V is the volume. Then when we are considering about the molar mass, then the number of moles, if W2 is the weight of the solid and M2 is the molar mass of the solid, then number of moles is equal to N2 is equal to W2 upon M2. We have to put this value into this equation. We will get the pi is equal to W2 RT by M2 V. Instead of that, we have to calculate the molar mass. M2 is equal to W2 RT by अशा पद्धतीनं आपल्याला हे मोलार मास या ऑस्मोटिक प्रेशरच्या सहाय्याने आपल्याला कॅल्क्युलेट करता